Alright everybody, it's about time we get into abstraction. Overall, abstraction is the process of hiding implementation details and showing only the essential features. Think of it like this. If I'm teaching somebody how to drive, I'm not going to open up the hood of the car and explain how the engine works. I'm instead going to tell the user that the gas pedal is to drive and the brake is to stop the car. Abstraction is the process of hiding implementation details. A user just needs to know what the gas pedal is and what the brake is. We can make classes and methods abstract by using this abstract keyword. This provides a few benefits. Abstract classes can't be instantiated directly. Abstract classes can also contain abstract methods, which must be implemented. They can also contain concrete methods, which are the opposite. These are real and physical methods, you could say. Concrete methods are inherited. So I know that's a lot. Let me give you an example. We're going to be creating an abstract class that can't be instantiated directly, meaning we can't create any objects from this class. In this demonstration, we're going to create some shape objects. Shape is going to be the parent. Then we'll have circle, triangle, and rectangle classes as its children. So we're going to go to New, Java class. We will create a shape class. Then a class for circle. A class for triangle. Then a class for rectangle. Our shape class is going to be abstract. We can't create any shape objects. Before the word of class, we will add this keyword of abstract. We can't create any shape objects. It's an abstract class. Now, circle, triangle, and rectangle are going to extend the shape class. Circle extends shape. Circles are a type of shape. Same thing applies with triangle and rectangle. Let's attempt to create a shape object. Shape equals new shape. And we get an error message. Shape is abstract. It cannot be instantiated. Since shape is an abstract class, we can't create any objects from this class. It adds a little bit of security to our program. We don't want anybody creating any generic shape objects. We want them to create a certain kind of shape, a circle, a triangle, or a rectangle. But we can create some circles, triangles, and rectangles, so let's do so. Circle equals new circle. Triangle equals new triangle. Rectangle equals new rectangle. We can create circle, triangle, and rectangle objects, just not shape, because it's an abstract class. That's good though, because we don't want people creating any shape objects. It's too generic. We want a user to pick a certain kind of shape. Abstract classes can contain abstract methods and concrete methods. An abstract method is a method which must be implemented by its children. Within our shape class, we will define an abstract method. Use the abstract keyword. Let's list a return type of a double. Every child class of the shape class needs an area method. I'll add a comment that this is an abstract method. Abstract. So within our circle class, we get an error message. Circle must either be declared abstract or implement the abstract method of area. Circle is going to inherit this abstract method of area from its parent of shape. We need to implement this method, so let's do so. This is going to be an overridden method. We need the annotation of override. We need to define a method of area. But we'll fill it in momentarily. Just for now, I'm going to return 0. And now that error message goes away. Since we inherit from the shape class, and there's an abstract method of area, we need to implement this method. This helps to ensure consistency among the children classes. You can see that we're missing that same method with triangle and rectangle. So why don't we copy this code, where we override the area method, and paste it. We'll be filling these in later. Going back to our shape class, abstract classes can contain abstract methods and concrete methods, which are kind of the opposite. Concrete methods are defined and inherited within an abstract class. Let's define a method of display. This method doesn't return anything, the return type is void. We'll just output the following. This is a shape. I'll add a comment that this is a concrete method. In an abstract class, a concrete method is inherited. Within our circle, triangle, and rectangle classes, we don't need to implement it. We don't need to override this method. It's inherited. Going back to our main Java file, if I was to take my circle object, call the display method, we get the following output. This is a shape. And that applies with triangle and rectangle too. Triangle.display, rectangle.display. This is a shape, this is a shape, this is a shape. This concrete method of display was inherited from the shape class, their parent. Now we'll define the area methods. Area is an abstract method. That means that the children classes have to define it. To calculate the area of a circle, we'll need a radius. We'll define that as an attribute. All circles will have a radius attribute, double radius. And we'll need a constructor, a circle constructor. When we construct a circle object, we have to pass in a double for the radius. This .radius equals the radius we receive. Now the formula to calculate the area of a circle will be, we're going to return, access the math class, access the constant of pi from the math class, times radius, times radius. That's how to calculate the area of a circle. Now for our triangle, we need the following. A double for base, a double for height. We need a constructor. Parameter 1 will be double base. Parameter 2 will be double height. This dot base equals base. This dot height equals height. For the area, we will return 0.5 times base times height. Then we have a rectangle. Double length, double width. We need our constructor of rectangle. Parameter 1 will be double length. Parameter 2 will be double width. This dot length equals length. This dot width equals width. Return length times width within the area method. And we're good. Let's go back to our main class. We're missing those arguments. We have to pass them in. For our circle object, let's say the radius is 3. For the triangle, the base and height will be 4 and 5. The rectangle, the length and width will be 6 and 7. We are going to output using system.out.println, take our circle, call the area method. Then do this with triangle and rectangle. Here's the area of each of our shapes, our circle, our triangle, and our rectangle. So that's the abstract keyword. Abstraction is the process of hiding implementation details from a user and showing only the essential features. That's why we've created a shape class that's abstract. We can't directly create any shape objects. We want a user to create a certain kind of shape, whether it's a circle, a triangle, or a rectangle. A shape is too generic. An abstract class can contain abstract methods, which need to be implemented by the children classes, or concrete methods, which are inherited, and the children classes will have access to it. Alright everybody, so that is abstraction and the use of the abstract keyword in Java. Alright, what's going on everybody? In this video I gotta explain interfaces using Java. An interface is very similar to an abstract class. In fact, there's a lot of overlap where you could use either one, but there's a few key differences. An interface is a blueprint for a class. It specifies a set of abstract methods that any implementing classes must define. One key difference is that by using interfaces, we can achieve multiple inheritance-like behavior. Normally with inheritance, a class can only have a single parent, but by using interfaces, a class can have multiple parents, like 2, 3, or more. So in this demonstration, we're going to create two interfaces. Let's go to File, New, Java Class. Rather than creating a class, we're going to create an interface. We will create an interface of prey, and the other for predator. File, New, Java Class, Interface, Predator. We're going to be declaring some methods, but not defining them. If a class inherits from the prey interface, they will have to finish defining a method of flee. The return type will be void. If you're considered prey, you need a flee method to run away. If you're a predator, you need to define a method to hunt, because you're a predator. Now we'll be creating three classes. File, New, Java Class. The first class will be Rabbit. Then Fish. We'll create a Fish class. And Hawk. Going to our Rabbit class. Rabbits are typically considered prey, not predators. Unless you count that one rabbit from Monty Python and the Holy Grail. That's the exception. Our Rabbit class is going to implement the prey interface. We get a warning message. Class Rabbit must either declare abstract or implement abstract method flee. Since the Rabbit class is implementing the prey interface, we have to finish defining this method that's declared within the prey interface. It's kind of like a contract. The prey interface is telling the Rabbit class, hey, if you're going to implement me, you need to define this method of flee. We'll need to do that in order to create Rabbit objects. We're going to be overriding this method using the override annotation. This method will be flee, void flee. And we'll want to add this access modifier of public. It's a publicly accessible method. In this method, we're going to output the following. Let's say the rabbit is running away. And that error should go away. Let's go back to our main class. We'll create a Rabbit object and test it. Rabbit, rabbit equals new rabbit. Let's take our Rabbit object, have it call the flee method. And this should work. Yes, the rabbit is running away. Now let's go to our Hawk class. Hawk will implement the predator interface. But we have to override this method of hunt, because with the predator interface, it's kind of like we're signing a contract. If Hawk is going to implement the predator interface, then we have to finish defining this method. We will add the @override annotation and define this method. And then again, we do need an access modifier. We'll pick public. Let's output the following. The hawk is hunting. Let's create a Hawk object. Hawk equals new Hawk. Our rabbit is fleeing. Let's take our Hawk object, use the hunt method. Okay, we have the rabbit is running away, the hawk is hunting. Now, rabbits don't have a hunt method, and hawks don't have a flee method. Now, one key difference with interfaces compared to abstract classes is that you can implement more than one interface. So fish, they eat smaller fish, and they flee larger fish. They could be considered both prey and predators. We will implement two interfaces. Implements prey, comma, predator. Then we need both of these methods. We have to finish defining both. Again, we're going to use the @override annotation. We will create a publicly accessible method of flee, where we will print the fish is swimming away. And we need a hunt method too. Add the @override annotation. This is a public method of hunt, where we will print the fish is hunting, let's say. All right, let's test it. We will create a fish object. Fish equals new fish. Our fish can flee, and our fish can hunt. The fish is swimming away, the fish is hunting. Our fish object implements both the prey and predator interfaces. It has to define these two methods. So that's one key difference with interfaces compared to abstract classes. A class can inherit more than one interface. Normally with inheritance, you can only have one parent. But this is a way around that using interfaces. Fish are considered both prey and predators. Alright everybody, so that is a quick introduction to interfaces. An interface is a blueprint for a class that specifies a set of abstract methods that implementing classes must define, and it supports multiple inheritance-like behavior. There's a lot of overlap where you can use abstract classes or interfaces. You should be familiar with both. And well everybody, that's a quick introduction to interfaces using Java. So yeah, it's about time I explained polymorphism using Java. Polymorphism is a Greek word. Poly means many, morph means shape. Together, you get the concept of many shapes or forms. It's a general programming concept. Objects can identify as other objects of different types. Objects can be treated as objects of a common superclass. A dog identifies as a dog, but it can also identify as an animal. It can also identify as an organism. It can also identify as an object. It can identify as more than one thing. In this topic, we're going to create a few vehicle objects. Let's create a few classes, file, new, Java class. We will create a superclass of vehicle. This class doesn't have to be abstract, but let's make it abstract. We can't create any vehicle objects. We will declare an abstract method that doesn't return anything. The return type is void. If you're a vehicle, you need a go method. So what we're going to be doing is creating a few different types of vehicles. A car, bike, and boat class, which will inherit from the class of vehicle. So let's create these classes, file, new, Java class. We will create a car class that extends the vehicle class. But there is an abstract method of go that we need to define. We will use the @override annotation. The method will be return type of void, go. All we'll do is output you drive the car. Alright, let's do this with a few other classes. I'll just copy this method because we'll reuse it. We'll create a bike class. Bike extends vehicle. And we need that method of go. You ride the bike. And a boat class. File, new, Java class, boat. Boat extends vehicle. You sail the boat. That is good enough for now. Going back to our main Java file, let's create these objects. Starting with our car. Car equals new car. Bike equals new bike. Boat equals new boat. Each of these objects has a go method. For example, let's have our car object use its go method, followed by bike.go method, and boat.go method. You drive the car, you ride the bike, you sail the boat. So let's say we would like to have a race. We're going to place all of these objects within an array, our car, bike, and boat objects. So what should the data type of the array be? Let's attempt to create an array of car objects and place our bike and boat objects within that array, and we'll just see what happens exactly for learning purposes. I will create an array of cars. The data type is car. It's an array named cars equals curly braces. Let's stick our car, bike, and boat objects within here. We're already getting a few error messages. Incompatible types. Bike cannot be converted to car. Bikes and boats don't identify as cars. Cars identify as cars. That's one of the shapes that bikes and boats don't have. They don't identify as cars. If this were an array of bikes, bikes equals our array of objects, well then we have another error message. Car cannot be converted to a bike. And you can assume the same thing applies with boats. Cars and bikes don't identify as boats. What we could do is declare our array of what they have in common. Well, our car, bike, and boat, they all extend the vehicle class. You could say they also identify as vehicles. We're going to change the data type of our array to hold vehicles. We have an array of vehicle objects. And then let's change our array name to be vehicles. Cars identify as cars, but also vehicles. Bikes identify as bikes, but also vehicles. Boats identify as boats, but also vehicles. That's the one thing they all have in common. They're all extending the vehicle superclass. They're also considered vehicles. That's another one of their forms, their shapes. For every object within this array, I would like to have each object use its go method, like we're racing. Well, what we could do is use a for each loop. What's the data type of the array? Well, it's vehicle. We have an array of vehicles. We will give a nickname of each vehicle as vehicle in my array of vehicles. For every vehicle in this array of vehicles, let's take each vehicle, call the go method, take every vehicle object, call its go method. Here's the result. You drive the car, you ride the bike, you sail the boat. Oh, and another thing I'm forgetting. Polymorphism can also be achieved through using interfaces. Let's delete our vehicle class. We'll create a new Java class. This will be an interface of vehicle. Rather than extending the vehicle class, we will implement the vehicle interface. We will declare a method of go that doesn't return anything. These methods do need an access modifier. Let's just say public. So polymorphism can be achieved this way too, through using interfaces, if you prefer interfaces. In summary, polymorphism means many shapes. It's where objects can identify as themselves, but also other objects. Objects can be treated as objects of a common superclass. And well, everybody, that is an introduction to polymorphism using Java. What's going on, people? Today I gotta explain runtime polymorphism, also known as dynamic polymorphism. How I would explain it in a single sentence is when the method that gets executed is decided at runtime based on the actual type of the object. In this demonstration, a user is going to pick a type of animal they want as a pet, a dog or a cat. But that's going to be determined at runtime, after the program is already running. We'll create a total of 3 classes. First, we'll create an animal class, which will be a parent class. We will create a class of animal. We might as well make this an abstract class for good practice. We don't want anybody creating any animal objects. We will have an abstract method. The return type is void. This method will be speak. When an animal speaks, they'll say something unique. We'll create a dog class. File, new, Java class. We will create a class of dog that extends the animal class. But we do need a speak method. We will use method overriding. The return type is void. With our speak method, we will output the following. The dog goes woof. All right, then we need a cat class. File, new, Java class. We will create a class of cat. Cat extends animal. And we'll just copy the speak method, just to save a little bit of time. When the cat speaks, we'll output the cat goes meow. That's good enough for this example. Since animal is an abstract class, we can't create any animal objects. I'll attempt to do so. Animal equals new animal. And we get an error message. Animal is abstract, cannot be instantiated. That's good though. Animals are too generic. We would rather have a user create a certain kind of animal, either a dog or a cat. In this demonstration, we're going to have a user pick if they want a dog or a cat, but we don't know which one they're going to pick. So why don't we do this? Let's declare an animal object, but not instantiate it. we will assign our animal equal to a new dog or a new cat based on the user input. So, animal, animal. This will either be animal equals a new dog or animal equals a new cat based on the user input. We will declare an object that's at least an animal. We'll accept some user input. We'll need a scanner. Scanner, scanner equals new scanner. We will pass in system.in and import this class, java.util.scanner. We'll need a prompt. Would you like a dog or a cat? We'll say 1 equals dog, 2 equals cat. I'll use print rather than print line because I like the input on the same line. Let's declare a variable of choice. This will be an integer. We'll use our scanner, call the nextInt method, and then we'll do the following. We'll examine if our choice variable is equal to 1. If it is, we'll finish instantiating our animal object, but we'll assign it to be a new dog object. Then we will have our animal use its speak method. So if it's a dog, it should go woof. Else if choice is equal to 2, then we will instantiate our animal object as a new cat and have our animal use its speak method. You could add an else clause, but it's not really necessary. This is good enough for now. Before running the program, we don't know what kind of animal we're going to create. It's either going to be a dog or a cat. If I select 1, we get a dog. The dog goes woof. If I select 2, we get a cat. The cat goes meow. The actual method that we call is determined at runtime, after the program is already running. Before we run the program, we know that we're going to use a speak method. We're just not sure which one. So that's runtime polymorphism. It's when the method that gets executed is decided at runtime, based on the actual type of object that we create. And well, everybody, that is an introduction to runtime polymorphism using Java. Alright everybody, today I'm going to be explaining getter and setter methods using Java. Getter and setter methods help protect object data, and they add rules for accessing or modifying that data. Here's a demonstration. We're going to create a class of car. File, new, class. We will create a car class. A few attributes that cars could have include a string of model, a string of color, and an int, let's say price. Then we'll need a constructor. We'll have 3 parameters: a string of model, a string of color, and an int of price. We will assign this.model equals model, this.color equals color, this.price equals price. Let's construct a car object. Car equals new car. Pick a model, a year, and a price. I've already used red Mustangs for too many examples. I'll pick something else. Let's say a Charger that is yellow, and the price will be $10,000. I don't know if that's good or not. We don't even know the year of the car. Anyways, so we have our car object. And then let's output these attributes just to test them. Car.color, I'll add a space character too, plus car.model, plus a space character, plus car.price. I'm intentionally not adding a unit of currency. So here's our car. I have a yellow Charger, and the price is 10,000. 10,000 of a unit of currency that you choose. But that's not important. With our car object, its attributes are publicly accessible, meaning we can view and change them easily. To demonstrate, let's say that the model of our car is now a Corvette. We have a yellow Corvette that is $10,000. We don't want the model of our car to magically become a Corvette. Once we assign its model to be Charger, we don't want it to change. What we could do when declaring these attributes is add this access modifier of private, preceding the data type. Private string model, private string color, private int price. We can't access them. And let's test that. You can see that the font color already changed to red. I will attempt to print the car's color, model, and price. Color has private access in car. Model has private access in car. And price has private access in car. Since these attributes are private, we can't normally access them outside of the car class. But there is a way around that, and that is by using getter and setter methods. Getter methods make a field readable. Setter methods make a field writable. Use get to read, set to write. We'll set up some getter methods first. I would like the car's color, model, and price. Here's how we can do that. Within the car class, we will create a method. We'll start with the model. The return type will be string, because our model is a string data type. We'll create a getter method, following this naming convention. Get, then the name of the attribute, model. All we're going to do is return this dot model. And then we'll do this with the color and the price. And I'll just copy this method because I'm feeling a little lazy. We have get model, get color, return this dot color, and get price. Return this dot price. Oh, and this returns an integer, not a string, because our price is an integer. Let's go back to our main Java file. Rather than accessing these attributes directly, because we can't, we're going to call these getter methods get model if you need the model, get color if you need the color, get price if you need the price. Replace car.color with car.getColor, and this is a method. Car.getModel and car.getPrice, and that should work. Yep, we can now read those attributes. We have a yellow Charger, and the price is 10,000. Another thing you can do too with getter methods, you can add additional logic. So with our getPrice method, let's instead return a string. We will return a unit of currency, I'll pick American dollars, plus the price. Let's see how that changes. Again, we are calling the getPrice method. There we go. Yellow Charger, $10,000. Getter methods make a field readable, and you can add additional logic when retrieving one of these attributes. And in this demonstration, I just added a $sign just to keep it simple. Then we have setter methods. Setter methods make a field writable. Going to our car class, we have model, color, and price. I don't want the model attribute to be writable. Once we've declared the model of our car, we don't want to change it. Our Charger can't magically become a Corvette, even though that'd be pretty cool. But the color you could change, you can paint your car, and the price. You can sell your car for a different price. We'll declare setter methods for our color and price, but not the model, because we don't want this attribute to be writable. So let's scroll down to the bottom. Following a similar pattern, we're going to create a method. The return type is void. This will be setColor. We have one parameter, a string of color. We will assign this .color equal to the new color that we receive. We'll do this with our price too. Void set price. We'll have one parameter, an int of price. This .price equals price, the new price that we receive. Okay, let's test these things. I'll attempt to access our color directly. Car.color equals, I don't know, blue. That's the first thing that came to mind. And car.price equals, you know what, the car's on sale. It's $5,000. Well, I can't change these. We still have that red text for color and price. because the color and price attributes are still private. Instead, we're going to call these setter methods. We will set the color and then pass in that new color, rather than assign it directly. Set color, pass in a new color. Set price, pass in a new price. 5,000. Then using our getters, we should be able to print these attributes. Yes, we now have a blue charger, and the price is $5,000. We don't have a setter method set up for the model. That's good though. We don't want the model to change. We only have set color and set price. If I attempt to access a set model method, we shouldn't be able to change it, because we never declared a set model method. It doesn't exist. But if you did want to change the model, if you want this attribute to be writable, well then you could add a setter method. Void set model. We'll pass in a string for the new model. This.model equals model. And then you could change it. We have a blue Corvette for $5,000, which is really cheap. But you know what? I don't want the model to be writable, just readable. If you don't want an attribute to be writable, when you declare it, you can also add this keyword, a final. That adds an extra security measure. One last thing we should do. With the price, let's add some additional logic. So with our price, let's do the following. Let's add a check. If our price is less than 0, then let's output the following. Price can't be less than 0. Else, if everything checks out, if our price is 0 or above, then we'll assign this.price equals the price that we receive as an argument. Let's test it. I'll change the color of my car to be blue, but the price is going to be -$100. We get that message. Price can't be less than 0. The color changed, but not the price. It stayed the same at $10,000. So those are getter and setter methods. They help protect object data and add rules for accessing or modifying that data. Getter methods make a field readable. Setter methods make a field writable. Depending on your object's attributes, you may want some to be readable or writable or both. It's up to you. And well, everybody, those are getter and setter methods using Java. All right, let's do this. Today I got to talk about aggregation in programming. Aggregation represents a has-a relationship between objects. One object contains another object as part of its structure, but the contained object or objects can exist independently. Basically speaking, an object can contain another object, but those objects can exist independently. What we'll do for this demonstration is create some book objects. Then we'll create a library object to contain the book objects. The books and the library can exist independently. That's aggregation. The library object will have book objects. We'll create a new class of book, file new class, book. And a class for library, file new class, library. Let's design our book objects. Let's say that books have a string of title and an integer for pages. You could include an author too if you would like, but I don't want this example to be too big. We'll need a constructor for our book objects. We'll set up the parameters. We need a string of title and an integer for pages. This.title equals title. This.pages equals pages. If you would like, you can set these attributes to be private, but that might be overkill for this lesson. Why don't we create a method to display the book's info? This method will return a string. We'll define a method to display info. We will display the info of this book. Let's return the following. Let's return this.title plus a space character plus this.pages and a string of the word pages. And I think I'm going to enclose the number of pages within a set of parentheses. You can also use a printf statement. if that's easier for you, but I want to try and keep this beginner friendly. Okay, that's good enough for the book class. Let's create a few book objects. We'll start with book 1. Book 1 equals a new book. But to construct a book, we have to pass in at least the following: a title and a number of pages. So I've picked out a few books already. Feel free to choose your own if you would rather choose different books. For the first book that I'll pick, I will pick The Fellowship of the Ring. This will be all one string. And the number of pages, at least according to Wikipedia, is 423. Then we'll create another book object. This will be book 2. Book 2 will be The Two Towers. The number of pages will be 352. And then book 3. Book 3 will be The Return of the King. The number of pages will be 416. Alright, we have our independent book objects. Then what we'll do is stick them all within an array. We'll create an array of book objects named books. Equals, then within a set of curly braces, we can place our book objects within here. Book 1, book 2, book 3. We have an array of book objects. Before moving on, let's test the display info method of each of these books. So we'll need a print statement. book1.display info. So we should get book 1, The Fellowship of the Ring, 423 pages. I'm just going to make one change. I'll put the right parenthesis at the end. That's better. Let's display book 2. The Two Towers, 352 pages. Book 3. The Return of the King, 416 pages. You could also loop through this array using an enhanced for loop. The data type of each element in my array is book. For every book in my array of books, we'll print, take each book, call the display info method. And here's all the books that I have in my array: The Fellowship of the Ring, The Two Towers, The Return of the King. And we can delete this for loop. We no longer need it. Now we're going to create a library object. Our library object will contain our array of book objects, because libraries contain books. Going to our library class. What should libraries have? Let's say that our library should have a name. What's the name of the library? Maybe a year in which the library was established, int year. And libraries should contain book objects. We will create an array of book objects named books. We'll need a constructor for the library class. We'll need the following: a string for the name of the library, an integer for the year of the library, when was the library built, and an array of book objects. This .name equals name. This .year equals year. This .books equals the books that we receive, this array. Alright, going back to our main Java file, this is where aggregation is going to come in. We will create a library object. Library equals new library. But we have to pass in the following as arguments to the constructor: a name for the library, a year for the library, and an array of book objects. So for the library, I'm going to say the NYC, the New York City Public Library. After a quick Google search, this library was built in the year 1897. Then we also need an array of book objects. I will pass in my array of book objects named books. This is aggregation. Our library object has book objects. Within the library class, let's also create a display info method for the library. We'll make it a little bit different. This method won't return anything. Let's say the return type is void. We'll name this method display info. We'll display the following information about this library. Let's output the following: the this.year of the library plus a space character plus this.name. You can also use a printf statement if you would prefer to use that. I'm trying to keep this as beginner-friendly as possible. So let's test this. We will take our library object, call its display info method. The 1897 New York City Public Library. Then within this method of display info for the library, let's also list all the books that it has. This library has aggregated a whole bunch of book objects, so then we can display them or use them for something. Let's output the following. Let's output books available. Then we'll use an enhanced for loop. The data type of what we're iterating through is book objects. For every book in my array of books, take each book, call the books display info method. And then we do have to print it using a print line statement, because this method returns a string. There we go. Let's test it. So after calling the display info method of the library, we should display the information of the library, including its books, the 1897 New York City Public Library, and we display the books available, which are the array of books that we have created. So that's aggregation. It represents a has-a relationship between objects. Our library object has book objects within it. There's another similar concept called composition. With aggregation, if you were to delete this library class, for example, I'll delete it. Well, these book objects can exist independently outside of the library. The books aren't built into the library, so they can exist independently, which is a key difference compared to composition, which is the next topic we'll cover. And well, everybody, that is aggregation using Java. Hey everybody, in this video I'm going to explain composition to you in programming. Composition represents a part of relationship between objects. For example, an engine is part of a car. An object can be part of another object. This allows for complex objects to be constructed from smaller objects. In this demonstration, we're going to create a car object. The car object is composed of an engine object. We will create a class of car and a class of engine. We'll begin with our class of car. What sorts of attributes should cars have? Let's say a string of model, an int of year, and an engine object. Engine, engine. We'll need a constructor. We'll pass in a string for the model, an int for the year. Now for the engine, we're not going to be passing in an engine object. Let's say that when we construct a car object, we have to pass in a string for the engine type. Is it an inline engine? Is it a V6? That sort of thing. We will assign this.model equals the model that we receive. This.year equals the year that we receive. Now with our engine, this.engine, we're going to call the constructor for a new engine object. And then we can pass in our engine type. But we still, however, have to set up the constructor for our engine class. When constructing a car object, we will also be constructing a new engine object. So let's go to our engine class. Let's say that engines have a string of type. You could say engine type, but that would be redundant, I would say. Let's just say type. Then we need a constructor. For our engine class, we will need a string of type to pass in. This.type equals type. So going back to our car class, when we pass in a string for the engine type, you could say that this is type. This term is kind of ambiguous though, because a user is going to think that the type is for the car type rather than the engine type. So when you pass arguments, your parameter names can be different from the argument names that you pass in. We simply rename them. when this constructor receives that argument. But type refers to the engine type. Alright, so this is a basic demonstration of composition. Now we'll construct a car object. Car equals new car. And then we have to pass in the following: a string for the model, an int for the year, and a string for the engine type. Pick a car that you like. This time I will pick a Corvette. The year will be 2025. And for the engine, I will pick a V8 engine. Then let's see if we have these details. I'm going to output my car objects, model, and these attributes I did not set to private, but you can set them to private and use getters and setters if you would like. So we have model, year, and we have an engine object. Here's what we have. We have our model, Corvette, year 2025. Now for the engine, our engine is an object. It's a reference data type. So if you output it directly, you're given a hash ID to represent that engine object. So if we need the type of engine, we're going to access our engine object, then get the type. So following our engine object, we will use that access modifier, that dot. Then access the type, the attribute. So the engine type is a V8. So it's like we have an object that's composed with another object. Our engine is part of our car. You know what? Let's create a method for the engine. We'll create a start method. Void start. We'll output the following. Let's say, using a print line statement, you start the plus this dot type, meaning type of the engine, plus the word engine. Then going to our car class, let's create a start method for the car class. Void start. When we start the car, we also start the engine. Let's take this dot engine, call its start method. And then we can output something else too if we would like. Let's output the plus this dot model plus the words is running. Now, if we start the car, let's take our car, call its start method, and we should get the following. You start the V8 engine, the Corvette is running. Now, a key difference with composition is that if we delete our car object, that should also delete our engine, because our engine is part of our car. So to demonstrate that, I'm going to delete our car object, and we no longer have access to the engine. Alright everybody, that is composition. It represents a part of relationship between objects. For example, an engine is part of a car. This allows for complex objects to be constructed from smaller objects. And well everybody, that is composition using Java. Well, look who showed up today. I gotta talk about wrapper classes. Wrapper classes allow primitive values, such as integers, characters, doubles, booleans, those sorts of things. Wrapper classes allow these primitive values to be treated as objects. We're basically wrapping primitive values within an object, kind of like a Christmas present. Generally, you don't need to wrap primitives unless you need an object for some reason, like if you're using a collections framework in Java. And wrapper classes also give you access to a lot of useful static utility methods. So let me give you a demonstration of wrapper classes. The method of creating wrapper classes I'm about to show you is actually depreciated, but it's going to help you visualize how this works, wrapping a primitive within an object. The modern approach is using a technique called autoboxing, but the method I'm about to show you is a good way to visualize this whole thing. So let's say we have an int of a, variable a. A equals 123. We can treat this primitive as an object by using a wrapper class. Here's how. Rather than declaring this variable as an int, we will use the wrapper class of integer. Integer variable a equals a new integer. And then we're going to pass in that number, that integer, as an argument. A is an object. we're passing in that primitive data type, that int, as an argument to the integer class. So a is an object, but it does contain a primitive value. Again, this is depreciated as of version 9, so you shouldn't do it this way, but this is a good way to visualize it. Then if you need a double, we'll use the wrapper class of double. Let's say variable b equals a new double. Then we'll pass in a double. 3.14 is good. Then we have char, which is character, that's the wrapper class. Character c equals a new character. Then pass in a character. I'll pass in a $sign. We'll add one more. Let's say a boolean. We will use the wrapper class of boolean. Boolean d equals a new boolean. Then pass in a boolean value. Here's just a few examples. These are all objects, a, b, c, and d. By wrapping these primitives within an object, that allows us to use these primitive values within collections frameworks, such as ArrayLists, which we'll talk about in the next topic. The modern way to use wrapper classes is actually just to assign them directly to their primitive values. The class of integer a equals 123. Double b equals 3.14. Character c equals a $sign character. And then d equals true. This technique is called autoboxing. We're directly assigning these primitives into an object using a wrapper class. Now, this is very similar to how we declare and assign strings. To create a string, you would say string, let's say e, equals a string of characters, such as the word pizza. You can see that there's a similar pattern. We have always created strings this way. But with autoboxing, it's a similar process. These are all reference data types. They're a type of object. There's also a technique called unboxing to convert a wrapper class back to its primitive. This is unboxing. So let's say we would like to convert our object of a, it's an integer object, back to its primitive. Let's say int x equals, all you gotta do is set it equal to your object. In this case, our integer object of a. This is unboxing. We're taking a primitive that's wrapped in an object and unboxing it, or unwrapping it, and setting it back to its primitive. If we were unboxing a double, we would say double, some variable, equals b. Or chars, char x equals our character object of c. And then boolean, boolean x equals d. Again, this is autoboxing. We're wrapping up a Christmas present. We're wrapping up a primitive within an object. And then unboxing is removing it. We're opening the Christmas present. Now, these wrapper classes themselves do have some pretty useful utility methods that are static. Let me demonstrate a few you might be interested in. But there would be too many to cover in just this one video. If you ever need to convert a primitive data type into a string, there's a toString method of these utility classes. So let's say we have string A, string B, string C, and string D. I can convert an integer into a string using the integer wrapper class. It's accessed statically, so we type the name of the class, integer, call the toString method, which is static, and then pass in an integer like 123. So let's do this with a double. We will access the double wrapper class, call the toString method, and then pass in a double, 3.14. Then to convert a character to a string, we would use the character wrapper class, character to string, and then pass in a character. And then boolean. We will access the boolean wrapper class, call the toString method, and then pass in a boolean. So strings can be concatenated together. We should be able to do the following. Let's say string x equals a plus b plus c plus d. And then we'll output whatever our variable x is. We get 123, 3.14 at false. It's all one long string. It's because we use these wrapper classes to convert these primitive data types into strings. If you ever need to convert a primitive to a string, Then use that primitive data type's wrapper class and call the toString method. Then you just need to pass that value in as an argument. Then it's going to spit out a string for you. Now on the other hand, to convert a string to a primitive data type, there's another useful utility method of wrapper classes. So what we'll do is parsing. We will have an int of a double of b, a char of c, and a boolean of d. Int a will equal, we're going to call the integer wrapper class, call a static method of parse int. We can convert a string to an integer. I will convert a string of 123 to an integer. Now with doubles, you will call the double wrapper class, and we will parse a double. We'll pass in a string of 3.14. Now characters don't have a parse method. What you could do instead is with any string, let's say we have a string of pizza, strings do have built-in methods, one of which is the char at method. Return the character at the first position, where index is 0. Again, character doesn't have a parse character method, so you would have to use char at, which is unrelated to wrapper classes. So then with the boolean, we would access the boolean wrapper class, call the parse boolean method, and we can convert a string representation of a boolean, such as true, into an actual boolean. And then let's output them. Now we shouldn't be able to add these together, much like what we did when we used the toString method. For example, string x equals a plus b plus c plus d. This isn't going to work, because we're mixing and matching different data types. And then if I was to output x, that would give us a compilation error. To convert a string to its primitive data type, there's various parse methods to handle that within our wrapper classes. It depends on the data type you're working with. There's a couple other miscellaneous utility methods within wrapper classes. I'll just cover two more. So let's say we have a char of letter. Pick a letter. I will pick the letter lowercase b. I'm going to use a printline statement. We can check to see if our letter actually is a letter. We can access the character wrapper class, call the isLetter method, and then pass in our letter. This returns a boolean, true or false. Is this character a letter? That is true. This would be useful for verifying user input. What if this was a $sign? Is this a letter? Well, this returns false. That is not a letter. I'll switch this back to lowercase b. There's also a built-in method to check to see if this letter is uppercase or not. There's a built-in utility method of the character wrapper class to check to see if this is uppercase or not. Character is uppercase, and then pass in our letter. Is it uppercase? Currently it isn't. That is false. But if it were uppercase, that returns true. Some of these utility methods of the character wrapper class would be great for verifying user input, like a username or a password. Alright everybody, so those are wrapper classes. We're basically taking a primitive and wrapping it in an object, kind of like a Christmas present. In the next topic, we're going to be working with array lists, and array lists only work with objects. So we need to utilize these wrapper classes in order to work with array lists. And wrapper classes do provide some useful static utility methods that you can always access. Alright everybody, and those are wrapper classes, and in the next video, we're going to cover array lists. Alright people, it's about time we get to array lists in Java. An array list is a resizable array that stores objects. You can store primitives. If so, you'll be using autoboxing, which we learned about in the last topic on wrapper classes. Arrays are fixed in size, but array lists can change. They're dynamic. Here's how to create an array list. First, we'll follow our similar pattern with creating many objects in Java. Array list, let's say list equals new array list. We will need to make one import. Import java.util.ArrayList. Following the type of array list, we're going to use the diamond operator. This has to deal with generics, which is a future topic. But for now, we're going to specify what type of object we're going to be storing within our array list. And you can always use the appropriate wrapper class to store primitives. For example, if you need to store integers, you can say integer. And then we do need that diamond operator after the second array list. You don't also need to specify the data type within the second diamond operator. Java can infer that. You're going to follow this pattern to create an array list. This array list can store integers. You just have to specify that type. So for example, let's take our list and add a few numbers. 3, 1, and 2. And then we can print our list, our array list. I will print our list. And we have 3 numbers, 3, 1, 2. Now, if you were storing doubles, you would set the type to be double and use the double wrapper class. 3.14, 1.99, 2.01. I'm just making up numbers here. There we go. So let's store strings. Let's create an array list named fruits. We will store the names of some fruit. So the array name is going to be fruits. And then we will print our array list of fruits. Think of some fruit. I will add an apple, an orange, a banana, and a coconut. That should be good enough for this example. And now we have an array list of strings named fruits. Apple, orange, banana, coconut. To add an element to an array list, you can use the add method. Add is a built-in method of array lists. To remove an element, you can use the remove method, then specify an index. So let's take fruits and remove the element at index 0. That should get rid of our apple. Then we have orange, banana, coconut. If we were to remove the element at index 1, that should get rid of our orange. Apple, banana, coconut. There's also the set method. Take our array list of fruits, call the set method. At a certain index, let's say 0, we can set that element to be something else. Let's replace apple with pineapple. Replace the element at index 0 with pineapple. Then we have pineapple, orange, banana, coconut. Or index 1 would be apple, pineapple, banana, coconut. That's the set method. With an array list, to get an element at a certain index, you can use the get method. Then specify the element number. Get the element at index 0. That's going to return apple. Get the element at index 1 would be orange. 2, banana, 3, coconut. You can also get the size of an array list. Take your array list, call the size method. That will return the total amount of elements within your array list. So my array list has 4 elements. To sort your array list, you will use the collections framework, call the sort method, and then pass in your array list. Our array list is named fruits, and then you do need to import this class. java.util.collections. After sorting our array list, let's print it. Print my array list of fruits. So these all should be in alphabetical order, starting with A for apple, B for banana, C for coconut, O for orange. So that's how to sort an array list. You can use the collections framework. You could use an enhanced for loop to iterate through all the elements of an array list. So the data type of my array list is strings. We specified that type. For every fruit in my array list of fruits, let's print each fruit. And here they are. Apple, banana, coconut, orange. Alright, so now we're going to cover an exercise. We'll create an array and accept user input. A user will enter in all the food that they want within this array list. So to help us with this exercise, we will need a scanner. Scanner scanner equals new scanner. Pass in system.in. Import this class. And then be sure to close your scanner at the end because I tend to forget. Scanner.close. we'll need an array list. Again, we'll follow a similar pattern with creating objects. Array list, let's say list equals new array list. Using the diamond operator, we're going to specify the type of what we're storing within this array list. We'll stick with strings. Let's rename our list as foods. We'll be storing some food, well, at least the name of food. We'll create a prompt. We'll ask a user, enter the number of food they would like to store. Enter the number of food you would like. And I'll use print rather than print line for the user input. We'll create a variable of num of food to store the number of food that we're going to store. Equals, take our scanner, call the next int method to get the next integer from the user. Once we accept an integer, we should clear the input buffer because there's going to be a new line character within there. Take our scanner, call the next line method to clear it. Let's do a test run. Enter the number of food you would like. I'll just say 3. And that seems to work for now. We have the number of food we're going to store within this array list. In my example, let's say I would like to enter 3 food items. Well, we could use a for loop to iterate 3 times. We will ask a user to enter in a food 3 times then. So we can use a for loop for that. Within our for loop, we're going to create a counter of I, meaning index. We could set that to be 0 or 1. Let's stick with 1. We'll continue this for loop as long as I is less than or equal to our number of food variable. If I would like to enter in 4 food items, this would be 4. So we should iterate this loop 4 times. We will increment I by 1 during each cycle of this loop. During each iteration of this loop, we will ask for a food item. I'll use print rather than print line. We will ask a user to enter food number, then I'll add plus our index of I. So during the first cycle, I is going to be 1, then 2, 3, 4, so on and so forth. Then I'll add a colon, then a space. We'll create a local variable of food. This will be of the string data type. We will set this equal to, use our scanner, call the next line method to get a line of text from the user. Once we have our string of food, we're going to add it to our array list of foods. So take your array list of foods, call the add method to add an element. We will add our string of food to our array list of foods. And then once we're done, let's print our array list using a print line statement. We will print our array list of foods. All right, let's test it. Enter the number of food you would like. I'll say 4. So we should ask for 4 food items. Enter food number 1. I'll say pizza, hot dog, hamburger, and then taco. And here's my array list of food. Pizza, hot dog, hamburger, taco. All right, everybody, those are array lists. An array list is a resizable array that stores objects. You can store primitives. You're just going to use Java's autoboxing feature if that's the case. Once you have your array list, there's various methods to add, remove, or set elements. And well, everybody, those are array lists in Java.